Hi everyone, my name is Chu and today I'm going to show you how to very well understand the multilinear regression model. Starting from the theoretical foundation of this kind of model, we will show you how to check the hypotheses that are hidden behind the multilinear regression. And after the theoretical foundation, we will take a practical example to illustrate in which case the multilinear regression is appropriate. So we'll for example take an example of a company's sales and show you how you can use multilinear regression in order to explain how sales can vary over the time utilizing factor that can be determined to the fluctuation of the sales of a company that is producing a specific good to the population, and we will show you how to utilize a multilinear regression in order to make a very strategic decision. Maybe you are a senior manager of a company or of your own company, or you are a senior executive officer on the company, and you are asked to build a model in order to use it to implement politic in order to improve productivity or sales of your company. So first of all, you need to know that multiple linear regression have a principle. The principle is that you have a variable to explain. The variable to explain can be a GDP, a gross domestic product of a country. Maybe you are economist in your country and your government asks you to explain why GDP fluctuate, what can explain the increase or the decrease of the GDP of your country. So you can build a model, a multi-linear regression based on some factor. Some factor can be many other variables, many other macroeconomic variables, such as investment of the government investment. Other variable can be government debt, indebtedness. Other variable can be any other macroeconomic variable that can have an impact on the GDP variation. So you can build a model based on GDP as explanatory variable, that we will need some factor called explanatory variable to explain your GDP, and your explanatory variable that we will use in order to explain the fluctuation of the GDP can be a binary or multinomial or any other variable like dummy variable. So in our practical case, as I said earlier in this tutorial video, I told you that we will take a cells. So you see that in this model that we are going to show you how to build based on sales of the company, our variable to explain here is sales of the product of the company. Maybe you are a senior executive manager and you are going to explain to a senior manager that what causes the fluctuation of sales, what can lead to the increase or a decrease of sales of your company. So to explain the sales, we will use the many variable semestrial variable of a company as a total market a potential market that a company can have can influence the sales. A product to client, a reduction to client can be a factor that is determinant in the realization of the turnover of your company. The price can be other factor that influence the realization of your turnover. So we have any other variable that can explain the sales, like research budget, the investment, the advertisement, the sale cost, and the total advert of the branch. So we will use this data building a multilinear regression model in order to explain how GDP, how sales vary over the time, because semester realization of our variable are semestrial, mean that every semester we have a realization of any variable that we will use in our model in order to make a policy for our company. So let's move back to the sales case. In our sales case that we will use to illustrate our tutorial video of today. So a variable to explain here is sales, and our explanatory variable are the total market, the reduction to client, the price, the research budget, the investment, the advert, the sales charges, and the total advert budget of the branch. So we will build a multilinear regression based on these different variables. So we can use our multilinear regression, for example, to make a prevision of sales, because sales is our main variable, our variable to explain. So while we will explain sales using different variables that we just highlight a moment ago, we can use some realization, some possibilities of scenario of realization of our explanatory variable, like total market, reduction of to client, price, and so on, in order to make a prevision of sales in the month. While when our model is built, we can use those realization of our explanatory variable that we call a scenario in order to make a prevision of sales if our model is very well built. So in the multilinear regression, is very interesting to look at correlation between our different variables. Maybe if you look maybe at price, for example, you will see that price is very correlated to the sales. If you look at this, not very correlated, but the correlation between price and sales are not very low. We can look at higher correlation, for example, between sales and the total market. When the total market, the positive correlation mean that sales and total market evolve in the same manner. So it can mean that when market grows, sales can also grow, or even if sales grow, it can even mean that the total market have grown. So that is the interpretation that we can have on the correlation. When the correlation is negative, it means that the two variables evolve in the opposite trend. So when one grow, another decrease. So according to the looking to the sales case, we can ask some question like what is the best model with one variable, what is the best model with two variables, or what is the best model without specification. What's the best model? Whatever is the number of variables, what's the best model that we can build based on our data and our explanatory variable. So we will answer to this question a little bit sooner. So we will show you the configuration of the data as we saw on the data presentation on the company sale. You will see that we have an explanatory variable that can be sales, as I told you, or a GDP, as I explained you in the first example. I'll take you about the economic model that we can build on based on multilinear regression. We have explanatory variable, and look at this table at the right of your screen. You can see that every variable, even if is a variable to explain or a dependent variable, or if it is there are explanatory variables, they have realization at any period of time. From the case of data that we present you on based on sales, there were semester period. This was semester, the variable was measured every semester. So the first semester, for example, we have the realization of any explanatory or the dependent variable. At the semester 1 or at the period 1, we have the realization of any variable. At the period 2, we have the realization of every variable, and so on to the period n, where we have the realization of any of our variable. So each model observe in the model that we are going to build, we will denote by YE the observed value that is considered as a realization of a random variable y defined by the relation yi equal a linear combination of our explanatory variable. So that's the specification of the multilinear regression, that y is the dependent variable or a variable to explain, and x1 to xk are our explanatory variable that will be used to explain our dependent variable. We'll suppose that our dependent variable is written as a linear combination of the explanatory variable, where our coefficient are denoted by beta 0 to beta k if you have k variable, and the term that we have here is called the error term, that's supposed to be independent and random and follow the statistical law, normal law of standard deviation sigma. That's one of the hypotheses of multilinear regression. So what's the problem about multilinear regression? We show you that multilinear regression can be, we suppose in the multilinear regression that our dependent variable is written as a linear combination of our dependent, of our explanatory variable. So what can we estimate our coefficient beta 0, beta 1 to beta k? What can we do to estimate this coefficient? What's the standard deviation of our error terms? What can we analyze our error term? That's also called residual term. What can we measure the linkage between our dependent variable of our explanatory variable? Because supposing that our dependent variable can be written as linear combination of our explanatory, mean that we suppose that is a higher hypothesis that we can measure using a concept or an indicator, tell the R squared, and that we will come back a little bit sooner in this tutorial video. So we can also look at the link between y and every single explanatory variable taken alone. That is the significance of a variable. We can also we can also look at global significance of our models. So the individual contribution of any variable, of any explanatory to the main variable, as I told you, is the significance of a variable. We can also have a problem of dealing with automatic selection of each variable. Good variable. If the variable is the good variable or not, we will see how we can deal with this kind of situation. We can deal with comparison of model to see what's the best model. We can do also prevision, as I told you at the beginning of this tutorial video. We can look also at confidence interval. So what is the notation of our multilinear regression model? So we suppose that the realization of our main variable is denote yi in our multilinear regression, and we estimate this realization as a combination of explanatory variable. That's called the calculated variable of y. Y calculated is the combination of explanatory variable, and y observed is what we see in the reality. That's also called the prevision. The prevision is also a linear combination when beta 0 to beta k are estimated. This combination is the prevision of y. The model will be better when prevision will be very close to the observed value of y, and we have some indicator that we will come back on it a little bit sooner. So the difference between the observed value and the estimated value is called the error term, and the least square method is the appropriate manner of estimating beta 0 to beta k in our multilinear regression model. So the aim of the least square method is to find beta 0, beta 1 to beta k, that minimizing the sum of the square of error. So we minimize the difference between the observed value and the estimated value. That's the fundamental principle that we use to estimate our coefficient beta 0, beta 1 to beta k. So we minimize the error term in order to find beta zero to beta k that are very interesting in our model. That's the least square principle. So using least square method, we can obtain some result. So you can see that we can, based on the data that I'll show you a little bit earlier in this tutorial, you can compute mean square. You can also compute the mean square of a residual. We can estimate our coefficient that are here in the first column of the standardized coefficient of our table. We have the constant here, the intercept, that's here. We have here the contribution of the total market in the realization of sales, and here we have a significant that we told you at the beginning of this tutorial. The significant, when that is considered as significant when the p-value, that's called the p-value, is less than a threshold that we can choose. Mostly the threshold is 5%. The threshold of significance is 5 to 10% to be able to use it to interpret a coefficient. The coefficient is only interpretable in the linear regression only when the variable is significant individually. So we look at our variable that are total market, the reduction to client, the price, the research budget, the investment, the adverts, and the reduction to client, and the sales cost and advice and total advert of the branch. We will see that only two variables are significant at 5% threshold. That's total market and advert that we can suppose in our first model that influence the variation, that influence significantly the variation of our sales, because our dependent variable is sales. So what can we interpret the total market using the coefficient? Our beta 1, because total market is our first variable, is 4.42. That means that when the total market increase by 1%, the sales will increase by 4.42%. That's the interpretation that we can give to this. And the price, for example, is not significant in our model because the p-value is superior to 10%. If we chose the threshold of 10% significance. But if the price was significant, we could have said that the price influenced negatively the sales, meaning especially that if the price increased by 1%, the sales will rather decrease by 30.52%. Same thing with the research budget. When the research budget increased, if the research budget was significant, the sale could have decreased rather. So we'll come back a little bit earlier in this in the interpretation of the multilinear regression. We can plot the prevision and the sales to see that in our model, prevision are a little bit closer to sales or realization. So we will improve our model in order to give it the best characteristic. You can also plot sales and prevision on the cell in the same and the simple linear regression. So residual analysis of the model specifies as principal variable equal a linear combination of our explanatory variable. The error must follow the normal law with mean 0 and standard deviation sigma that is to determine. So in our residual analysis, we should check that our error term is follow the normal distribution. So we can consider that our standardized residual is very high if it is superior to. So coefficient determination is measured by R square in the and by R, the R in the multilinear regression. So using the decomposition that follow, and the decomposition said that the total sum of square of in our model is equal to the sum of explained square and the sum of residual square, and then we define the R square and the ratio of total sum of square of the sum of explained square over the total sum of square. So the R square, when R square will be close to 1, the best our model will be. So when R square is very slow, that means that the correlation between our model in our model is not very well. That means that the linear regression cannot be appropriate. So in the multilinear regression, the model will be good when the R square will be as closer to 1 as possible. So we will show you also how to measure the global linkage between our main variable and the explanatory. The global linkage means that you can answer the question, is it at least one variable that can be supposed to be significant? So we will do the hypothesis test, where the null hypothesis is every coefficient is our model except the constant is 0. That means that our factor that we chose at the beginning are not significant globally. So we were wrong choosing x1 to x car as factor, and the alternative of our hypothesis is that at least one coefficient is different to 0. That means that we can find again among our covariant that we chose at the beginning at least one that can be used to explain our main variable. And to do this test, we use Fisher statistic, and we take decision using the percentile of Fisher's Nedekorf distribution. We can look at marginal contribution of every variable. Is it significant when we take one of our covariant individually? Can we say that his coefficient is statistically different to 0 or equal to 0? We will do the hypothesis test, where The null hypothesis is our coefficient of our variable that we choose, of our factor that we choose, is null against alternative hypothesis in which we suppose that the coefficient is statistically different to 0. And to do that, we'll use a student statistic to take a decision after student calculated is superior to the percentile of student distribution. So we come back to the first estimation of our model, in which we have different coefficient where only the total market and outbreak were significant. We will show you how to move or add variable in order to have a best model in which the R square is maximum, and and many of our variables are significant, so that we can use it to make a policy to propose policy in order to improve sales of the company. So to do that, we'll do a step-by-step regression. When your model is not very good, when you see that many variables are not significant in your model, that means that you can remove some variable to improve the quality of your model. It means that you are wrong when you are putting all your factor in your model, so we need to remove some of them in order to improve the quality, the R square, and to improve the prevision of cells. So the principle of step-by-step regression consists of considering all of our factors, or all of our explanatory variables that we have at the beginning, at the start of the multilinear regression. We'll estimate, we will be removing step by step any variable that have a minimum contribution or a maximum, that we're removing the variable that has minimum contribution to the explanation of our explanatory variable, or of our main variable that we are going to explain. At each step of the step-by-step regression, the variable that will have a highest p-value will be removed, and we will re-estimate our model without the variable that we have removed. And we will do it step by step. We will do it until we have every variable of our model significant at 10%. 10% is the threshold chosen in many statistical software that are used in order to estimate the step-by-step regression. In SPSS, for example, the threshold is 10%. So we will remove step-by-step the variable that will have a highest p-value until at the end we have any of our variable significant at least at 10% threshold. So in the first step, we have our model that we show you a little bit earlier in our practical phase. So you will see that is the first step. In the first step, the R square of our model were 0.18. 0.18, that is not bad because it's very close to 1, but we can improve it by removing some of the variable at this stage, as a total advert of the branch is the highest has a highest p-value. The variable will be removed at this stage, and we have at the stage 2 a model estimated without total sale that we had in the first stage. So in the second stage, you see that R square didn't really vary. R square stay the same, but we have now two variable significant, but the p-value have very improved in our model. So in this stage, the variable that has a highest p-value or a lowest contribution to our model is the research budget that have a 0.60 p-value. So the research budget will be removed at this stage, and we'll delve into the third stage of our step-by-step model, and we see that the R square maybe stay the same, but the variable that were non-necessary in our model were removed. And in this case, we saw that sales cost is a variable that has a highest p-value. So sales cost will be removed in our model at the stage 3. Let's move to the stage 4. At the stage 4, you see that there is also a variable, the reduction to client, that is still not significant in our model. So we will remove reduction to client and go to the final stage, because any other variable are significant at 10% threshold, 10% risk. So at the last stage, we have a p-value, a R square that maybe have decreased, but the R have increased according to the previous stages. So we have a fifth stage of our model where all our variables are significant at 10% threshold. So we can really interpret our coefficient in order to tell to our managers what decision to take in order to improve sales. Let's move to the interpretation of our finite model obtained by the step-by-step estimation. Now that all our variables are significant at 10% threshold, we can make an interpretation of our model using coefficient of the estimation, standardized coefficient of our model. So let's look at total market. We'll see that the total market coefficient is 5.19%. That is significant at 10% threshold. That means that if the total market increased by 1%, the sales will also increase by 5.19%. Contrarily, you will see that price fluctuate in the contrary manner as price, meaning that when price increase, sales decrease, or when price decrease, sales increase. Precisely, very precisely, when price increase by 1%, sales will decrease by 13.17%. And investment have another impact, positive impact on the company sales, especially when investment increase by 1%, sales will increase by 1.96%, almost 2%. And concerning advert, we see that advert influence significantly sell, and especially when adverts increase by 1%, sales will increase by 8.22%. And the decision that we can take that is that company can manage, can use policy based on advertisement. For example, if it want to increase sales, managers should focus mostly on advertisement, because advertisement is the variable that have the best impact, the highest impact on the sales of the company. So investment, we can act on investment, but a variable like total market, a company cannot really influence on the total market, because the total market is not defined by the company, but the variable that in which the company can act on is price, investment, and advert. So advert and price are very sensitive variable, because decreasing a little bit price can have a highest impact on the sales of the company. Maybe we can look at cost, that the variation will lead to, in order to choose the best policy to your company. And that's the end of this. You saw how you can use multilinear regression in order to resolve concrete problem, in order to establish a marketing strategy of a company, and in our next video tutorial I will show you practically in the software, especially our software, how to estimate coefficient of multilinear regression very soon.